name is Wong Kelly. I'm going to talk about the Hplc type of sample. Hplc is a form of column chromatography that pumps a sample mixture or analyte in a solvent known as the mobile phase at high pressure through a column with chromatographic packing materials, stationary phase. The sample is carried by a moving carrier gas stream of helium or nitrogen. Hplc has the ability to separate and identify compounds that are present in any sample that can be dissolved in the liquid in trace concentration as low as parts per trillion. Because this is versatility, Hplc is used in a variety of industrial and scientific applications such as the pharmaceutical, environment, forensic, and chemical. Definition of the technique used in the analysis of sample. Hplc stands for High Performance Liquid Chromatography, sometimes referred to as High Pressure Liquid Chromatography. High Performance Liquid Chromatography is a powerful tool in analysis. It yields high performance and high speed compared to traditional column chromatography because of the forcibly pumped mobile phase. Hplc is a chromatographic technique that can separate a mixture of a compound. It is used in biochemistry and analytical chemistry to identify quantity and purify the individual component of a mixture. Thank you.
Today I would like to present about preparation of sample in Hplc and the method of analysis in Hplc. So first of all, we see the preparation of sample. If we want to prepare sample of caffeine, and then we just go through for the caffeine. So if you want to prepare any other sample, you can follow this method also. For Hplc caffeine, we have to weigh 10 mg of caffeine and then transfer the caffeine into a clean 100 ml of volumetric flask, and then we dilute it with the Hplc grade water, and then after that we carry out several serial dilution with a different concentration, and then we have to shake or we just sonicate each the mixture to make the dilutions, and then filter the solution using provided filter. Do not do this until you are ready to run your sample. After you just did this procedure, you have to run the sample immediately. To filter and syringe can be reused if the solution are filtered from the low concentration to the highest concentration. Filter approximately 1 ml and dispose of it into waste beaker. So we just can wash it or throw it away, the syringe. Filter the solution into a appropriate vial. Do not put tape on the vial and ask for Shafy to label it. What vial is a small dilution bottle where you can see here. Then we go to the method of the analysis of Hplc, and this is a diagram where Hplc could be worked. So first is solvents reservoir. This is a solvent reservoir, and then solvent decayers. Number 3 is gradient valve, the other, and number 4 is mixing vessels for delivery of the mobile phase. Number 5 is high pressure pump. Number 6 is switching valve in inject position. Number 7 is sample injection, and number 8 pre-column or guard column. Number 9 is analytical column. Number 10 is detector. Number 11 is data execution, and number 12 is waste of fraction collector. How does this work? Hplc. In a very little amount, the sample mixture could be separated and tested is sent into the stream of mobile phase. Pre-collecting via a column. There are different types of columns available with sorbents of varying particle sizes and surfaces. The mixture moves through the column at varying velocities, also known as the stationary phase. The velocity of each component in the mixture depends on its chemical nature, the nature of the column, and the composition of the mobile phase. The time that mobile phase is referred to the retention time. The retention time is measured under specific conditions and considered as the identifying of characteristic of given analyte. Sorbent particle might be hydrophobic or polar in nature. The common use of mobile phase included any miscible combination of water and organic solvent such as methanol. Water-free mobile phase can be used also. The aqueous component of the mobile phase might contain acidic like formic, phosphoric, or salt to enable the separation of the sample component. The composition of the mobile phase is either maintained as a constant during the chromatographic analysis. The constant approach is effective for the separation of the sample components that are not very dissimilar in their affinity to their stationary phase. In varied approach, the composition of the mobile phase differs from the high to the low to high eluting strength. The eluting strength of mobile phase is reflected by analyte retention times, where high eluting strength produces fast elution. Thank you.
Next is the suitable parameters that use in HPLC. First of all is the retention time. Retention time refers to the time which is required of the component from the moment of injection until the moment of the detection. Accordingly, it's present in the time of the analytic is in the mobile and stationary phase. The retention time is the substance specific and should always provide the same values under the same conditions. In chromatogram, different peaks corresponding to the different components of the separated mixture. Time elapses between sample introduction and maximum of the response. It is the characteristic it takes for a particular analytic to pass through the system. Time taken for the analytic to travel from the column inlet to the point of the detection, which is maximum volume. Retention volume is the volume of the carrier gas or liquid required to elute 50% of the component from the column. It is the product of the retention time and follow rate. Retention volume equals to retention times by the follow rate. Resolution. Resolution is the measure of the extent separation of the two components and the baseline separated achieved. And this is a formulation for the resolution.
In HPLC, we do separate and derivative of the compound of measure of compound related UV light evaporation, and we most focus on the compound of interest before we start our experiment, and that's why we need 4 compounds to build to HPLC method, and if before running any sample containing that compound. The sample is carried by a moving carrier gas of helium and nitrogen. HPLC has the ability to separate an innovative compound that are present in any sample that can be deposited in the liquid in concentration as low as the trillium. So, possible result of HPLC. Possible result of HPLC. Of the sample measure, we refer of how much compound have in the measure, and the area eliminated are more polar. The compound in most interactive with mobile phase contain more organic base, and use the time of reaction of the period will be able to know which one concentration to your compounds by comparing to the 4 compound run under same concentration, which is the area visual peak will refer to the concentration of the compound in the sample. As the sample bursts across the column in interaction between the two pastes is different rate. Primarily due to different quality in analysis, they have the less amount of the interaction with the sensory paste or the most amount of interaction with the mobile paste with the column faster. Then the column of interaction and the higher percent will accordingly refer to which compound has been spared effortlessly. So you only reserve you will only give a small.
Hplc has been used for manufacturing, research, and medical purposes such as in pharmaceutical, environmental, and clinical. Hplc can be used to improve the quality of health or environment. For example, in pharmaceutical, Hplc were used for quality control of pharmaceutical formulation and identification of counterfeit products. Hplc can be used to improve the quality of the product by extending the shelf life of the pharmaceutical product. Other than that, by using the Hplc technique, new drugs can be created for existing disease by analysis of any drug to confirm the identity of a drug and provide the quantitative result, and also to monitor the progress of the therapy of the disease. While in the food industry, Hplc can be used to improve the food product by detecting and quantifying the vast majority of the food analytes to ensure the quality and the safety of the food supply. For example, mycotoxins are highly toxic compounds produced by the fungi. They can contaminate food products when storage conditions are favorable to the fungal growth. However, the analysis of individual mycotoxins and their metabolites are difficult. Hplc can be used for detection in a low parts per billion range and can be performed using suitable sample enrichment and sensitive detection.